All right. Check, check, check. All right. I think we're, all right, I'm mic'd. Welcome, everybody, to day 2 of Øredev. I hope you had a good time at quiz night. I'm surprised everybody's here and on time, so wasn't too disastrous. Got enough sleep, I hope. And today, just to announce, if you were here the last few years and Ben was hosting, he's actually here today. So please find him and say hello. And I haven't seen him yet, but I hope to see him soon. So one thing I want to remind everybody of is it's really great that you're live tweeting about the talks, because often we want to see a couple of talks at the same time, but we can only pick one. But so the live tweeting and the notes from the other talks are really helpful because you get to have a chance. So please keep doing that. And just a reminder that the information booth is out in the middle of the exhibition floor, and it's there for all your needs. And I asked yesterday, and they said they've gotten no weird questions. So I think we can do better than that. So make use of it, let them know, ask for what you want, and throw a few weird questions their way just for their entertainment's sake, and mine also. So just a reminder for that. So today, what we have left, we're starting, of course, at 9, and we're going late tonight. So the key for today is to pace yourself. And we're going to end at 7:30 here, take a short break, grab a beer, and then we're going to have a comedian, Jen Brister, here to, she is really funny, so she'll be very entertaining. So make sure you stay for that. And then there's an after party. We have we have an opening and closing keynote again today. We're going to start with Marianne Bellotti, who is an expert in legacy systems, and we'll end with Nicholas Modig, who is an expert in operational excellence. And both are really fun people. I had the chance to interview them before this, to introduce them. And then, of course, the after party. And I want to say last year at the after party, I hung out with someone I already knew. Her name is Judy Reese and her husband. And we'd already known each other, and we're just hanging out and watching the entertainment. And we had a few too many beers, I will admit. And we're sitting there at the table, and we're like, we should totally work together. Yeah, we should totally work together. And 1 year later, I should say that my collaboration with Judy, we created a workshop together, and it's selling like hotcakes. So I just want to say, use this time to meet and maybe open yourself to new experiences, because you never know what magic will happen. So have fun at the after party. And like I said, please, today, because it's a very long day and we've already been going already, please practice good self-care. Make sure to drink enough water, get enough food, take a rest if you need it. If you need to find a quiet place and you can't, just let me know, I will help you. I know how important that is. So just make sure, really pace yourself today and take really good care of yourself so we can make it through the whole day and have a really, really good time. So yesterday, I chose the theme of try something new. And today, sort of in line with psychology, I wanted to choose the theme of listening to learn. And it's actually something I learned from Judy Reese. So we're going to do a short exercise as an icebreaker to give you a listening tip for something that you can use throughout the day, to use listening as a way of learning about somebody. This is a really fun one. So Marianne, if I could invite you on the stage to help me quickly with this exercise, I want to show people what I'd like you to do. So you're just going to talk to the person next to you about anything at all. It could be sports, the weather, some hobby that you have, whatever it is that you want to talk about. And the person listening is just going to ask you questions. And those questions are, what kind of X? Or is there anything else about X? So I learned this from Judy. It's part of clean language. I am no expert in this, but I promise you that with these Jedi questions that you can use it to learn a lot. So Marianne, tell me something about something you like.
I really like to dance.
Oh, what kind of dance?
Well, I'm currently studying tango, actually.
Ooh, is there anything else about tango that you like?
It's like when you find the right place to study, it's very social. You don't have to have a partner. Everybody dances with everybody else. So it's like a really great way to sort of meet people and build a community.
Ooh, what else about meeting people do you like? See how easy it is? So this is what I'd like you to do. And just practice these 2 questions, because I promise if you use them throughout the day, you will find connections that you never thought you could find before. So just for 1 minute with the person next to you, and then after 1 minute, we'll switch. So just to practice. So please. All right, go ahead and switch partners now. Switch partners, or with the same person, have the other person talk. All right. That wasn't so hard, right? It's all right. And maybe you found something that you didn't know before. So thank you for indulging and thank you for trying something new with me. So before we get to the keynote, I just want to say we have partners on the exhibition floor, and they are the ones that really make this conference happen. So please visit them and see what they've got to offer. There's some really cool things out there. And also, you may have seen there is a sign called Best Companies. And what this means is these are all companies that have chosen to send 10 or more people to this conference. So as you're walking around, probably there's somebody from this company out there in the audience. So that's just something to know, and there's a banner in the exhibition hall as well. So you know the drill. Before the next keynote, I'd like you to stand up. We have 50 minutes. Just stretch your legs, stretch your arms, get some blood flowing. Mind your neighbor. This is really a beautiful sight. I wish you could all see it from here. All right. Shake it out. Here we go. So, our first and opening speaker of today, you've already seen her on stage, Marianne Bellotti. Just like Adam yesterday and many of you, she started, her first computer was the Commodore 64, and she started writing code at the age of 13 and then spent many, many years wondering, how can I avoid becoming a programmer? Because at the time, there weren't really cool companies around, and all the programming jobs were like insurance companies and banks, and she thought that that wasn't that interesting. But she failed and became a programmer anyway. And some things that you might not know about Marianne is that she dances the tango, which actually you do now know, and she once had a job in which she was paid with cake. So, beat that. She is now a specialist in modernizing legacy systems, and it's my great pleasure to welcome her to the stage. Please give a big round of applause for Marianne Bellotti.
Focus in. Make sure this is on right. Yeah, all right. Good morning, everybody. So, as previously mentioned, my name is Marianne Bellotti. I did try to escape being a software engineer for a very long period of time for exactly the reason that laid out. But I ended up here, and basically, if you count the years that I started at the age of 13 as a script kiddie on the internet, I've been a software engineer for anywhere from 15 to 20 years. What I was trying to do when I was trying to escape the world of software engineering was become an anthropologist, right? So that's something that I think is really important in background for this talk in particular. I have a bachelor's degree in anthropology and a master's degree in organizational science and management. And all throughout my formal education, the question I got the most often, mostly from my family members, was, what on earth are you going to do with a degree in anthropology? Like, what do you do for work with a degree in anthropology? How do you make money with something like that? And the answer to that question, it turns out, is you deal with really messy legacy systems and how to restore them back to their operational excellence. So, Mostly, when people think about technology, we tend to assume that technology is objective and rational and math-based. But the reality is, technology is built by people who most definitely are none of those things. So what happens is that we incorporate a lot of our biases and our cultural constructs into how we build technology and how it's shaped, which makes technology, from an anthropologist's point of view, an actually really fascinating area to kind of like dig into. I think the industry, in a more broader sense, is just now starting to become aware of these factors as we get further and further into AI and machine learning. And we're realizing that algorithms that were built to be objective and rational are actually like inheriting a lot of our racial bias and gender biases along with them. But let's come back to this idea of legacy systems, which I use with the metaphor of a tire fire because they often feel that way, like they're falling apart and messy on all fronts. And right now what I do at Auth0 is a much more modern company, so it doesn't really have COBOL mainframes and like some of the stuff that I've seen elsewhere in my career. But I've found that the techniques that I would use on the very, very old systems also work really well for maintaining more modern systems, right? Because there are really two ways that legacy systems end up in a mess. And the first way is kind of what I would say the traditional way. We built something, it was great at the time, and then we literally invested no time and no energy into maintaining it at all. We just kept pushing new features and tacking new stuff on it and like making small changes that we could sell, but no like significant architectural changes, no looking at how it was going to scale long term. And now we have this huge mess where we don't know what to deal with. But the second way that legacy systems end up in trouble is the exact opposite, is that we make too much of an effort to modernize. We are constantly jumping on the next best thing. We're constantly shifting the architecture of our system, even when it doesn't make any sense to do so. And usually what happens is we burn out our engineers, and we also end up with a whole bunch of partial migrations. So we end up with like this Frankensteinian system that has no kind of consistency at all with one another. And so this opens up the big question, which is, when exactly do you modernize? If you don't want to just build a system and leave it alone forever and ever, and you don't want to build a system and like constantly update it as soon as the trends come out, like when exactly should you modernize? So let's start with a scenario. I'm going to give you a description of a piece of technology, and let's see if anybody can guess what it is. It has a complicated, expensive infrastructure. It requires a highly specialized workforce to maintain it. It's huge, physically huge, so it has huge space and cooling requirements. But on the upside, if you own this technology, you can rent it out to other people and sort of offset some of those expenses. Anybody want to take a guess what this is describing? So it's a mainframe, right? It's clearly a mainframe, right? So in a later part of my career, I encountered a lot of these things, and that mainframe pictured is actually like a modern day mainframe, right? It's like a IBM, I think, 2010, 2012 model of the ZOS system. So it's very flashy. It looks a little bit like a gaming desktop you might buy to like play video games. It's about the size of a refrigerator. And generally speaking, the mainframes that I was interacting earlier in my career were like the size of rooms and not that nice. But still, it's a mainframe. And generally speaking, when I come into a legacy system that has a mainframe, the thing that people most want to do is, let's move it to the cloud. That will be awesome. Everything will be better if we move it to the cloud. Problem solved. Just tell us how to move it to the cloud. And my first reaction to that is usually, cool. Why? Why the cloud? What are the advantages of the cloud? And the things that people say is they go, well, you know, like data centers have complicated, expensive infrastructure, and they require a specialized workforce. But the big advantage of it is that we're not going to own any of that. Amazon's going to own that, and then we're going to pay to use their time. So the person over here who, when I asked, like, what technology is this describing, said AWS, you get a point. Because there is sort of this weird commonality in the patterns that we developed with the original mainframe era of computers and the patterns that we're pushing now with cloud. And this idea was kicked off in my head when I was working on one of these legacy systems and I was talking to a COBOL programmer. And he was very cynical about the modernization effort we were running. And he kind of said, you know, like 15 years ago, we had these green screen terminal applications, thin client, talks to the mainframe does all the processing for you, sends your data back. And a bunch of people, a bunch of consultants came in and said, no, this is passé. This is out of date. You need a thick client on a PC. You need to move all that logic to an application you can run on a desktop machine. That's modern computing. Your mainframe is obsolete. It's a dinosaur. It's going the way of it. And he goes, and now what are people saying? Like these same consultants are coming to us and saying, no, you need APIs, which are functionally thin clients that outsource a lot of their data processing to a data center and return the data back to you. So he's like, people can't make up their mind. They tell us one thing, and then they change their mind, and they tell us the exact opposite thing is modern computing. And like, why should we bother migrating to anything at all? Just figure out what you want and get back to us. But it kicked off an interesting idea in my mind, because even though this is slightly oversimplified, he did have something of a point, that the design patterns that we were using from a very old stage of computer history were actually kind of reoccurring in modern computers as well. And so that ticked off this question of like, how does technology advance exactly? Because most people assume that technology advances basically in a linear path. And when you are operating under that assumption, anything that is new is inherently more advanced than the thing that came before, right? But when you actually start to look at like how computers have evolved through history, what you'll see are these kind of cycles. So we did take this little detour through PCs and applications that were designed to run on PCs. We went from these massive mainframe data centers that we were like remoting into and like pushing our data and getting it back out to PCs, and then back to these massive data centers where we're sending our data via remote means and getting it back. And if technology advanced in a linear fashion, then what we would expect to see is that the mainframe would have eventually evolved into the cloud, right? That's what we would expect to see if we were actually going in a line. And there are actually like lots of different examples of this. So this is a tweet I pulled off the internet a couple months ago, and what I like about it is that it's the exact same reaction I had to people talking shit about enterprise service buses. That like when you look at like message queues and things like Kafka, a lot of what we're doing with them and the way we're configuring them is just reproducing what we already had with this very passé, uncool technology of enterprise service buses. And here's another one from a little bit later that's talking about Google's press release announcing server-side rendering. And I totally get it, Google. I was really excited when I learned about this technology in the 90s as well. It's really cool. So like we see that we are constantly reinventing things, often without knowing it. Like it's not like we're going back and being sneaky and pulling something and like dusting it off and representing it as a new thing in order to like make lots of sales. We don't realize that we're reinventing these things over and over and over. We honestly think that they're new paradigms and new design patterns. So, how many people here have a mobile phone with them? Yeah, every hand. All right, great. So I'm going to start off breaking this down via the story of mobile phones, right? So I'm going to start off with the following question. Is it better to have a big phone or a small phone? How many people think it's better to have a big phone? We're going to see about that. The size may in fact matter. How many people think it's better to have a small phone? Okay, a lot of small phone people. Interesting. So some of you, I imagine, have seen this meme. It was going around Reddit for a while and various other internet channels. And this meme is funny because it encapsulates a general truth about the development of mobile phones, right? We started off with the brick phones from the 80s, and then they got smaller and smaller and smaller and smaller and smaller, and nowadays they seem to be competing to get bigger and bigger and bigger and bigger and bigger. But there are two things that are wrong about this meme. The first one is that it actually has nothing to do with porn. But the second thing is they also have the time wrong. They have it set at about just before 2005, so somewhere in the the area of 2002 to 2003, and we actually know when this shift started to happen. It was around 2010, so late 2009, early 2010. And if you want to look at the data, this is basically that visualized. So the lighter blue colors are small screen sizes, and the darker blue colors are large screen sizes. And so you can see 2007, we're basically overwhelmingly small phones, small screen sizes. And then we start to get in 2008, a little bit more diversity, but mostly small screen sizes. And then we start to get up to 2009, and like the last half of 2009, there's an actual line where we see like a spike in some small screens, but we start to now see a downward trend where we're getting larger and larger and larger screen sizes once we get into 2010 and onward. And this chart is actually a little bit cleaner, a little bit easier to see, where there's like a very clear dip where we get to we bottom out around 2010, and then we start rising in our screen sizes as well. So the question becomes, what the hell happened in 2010, right? So most people kind of just go, well, it's the iPhone, right? It's got to be the iPhone. The iPhone changed everything. People were waiting out on lines for hours and hours around blocks and blocks, so it has to be the iPhone. But actually, the iPhone was released in 2007, so that's a bit too early for the reaction that we're seeing. And if you look at like the notable events in those early stages of the iPhone, there's really nothing around that period of 2009, 2010, right? We have the launch of the iPhone in 2007, and then in 2008 we have the launch of the App Store, and then in 2011 we have Siri, which is a bit too late. And in fact, the size of the iPhone itself has not actually seemed to push the needle all that much on screen sizes in and of itself. When it first came out, it was really only about 1/2 an inch, which I think is like 1.25 to 7 centimeters bigger than the average was at the time. And then it stayed very consistent until about 2012, where they had to up it about an inch more in order to stay competitive with the other phones that were on the market. So Apple is not driving this forward. If anything, Apple is reacting to it. So what could it possibly be? Like, why are we seeing a dramatic shift in like what we're optimizing for with cell phones? The answer to that is kids, specifically teenagers, right? So there's an organization in the United States called the Pew Research Center, which does these multi-year research projects specifically around technology. They particularly like the internet and mobile phones and its impact on American society. And so in their 2009 study, they released a report specifically about kids and mobile phones, in which they said like the medium of communication for teenagers were still landline phones, right? They were still doing most of their communication over their landline phones, which makes sense because teenagers in general are cheap and landlines are paid for by their parents. And so like free phone, like versus phone I must pay for, that makes a lot of sense. But by 2010, teenagers are now texting, and they're texting in much higher numbers, and it's growing very quickly. So what we see is that before 2010, the principal purpose for a cell phone was business. And if you even go back to the original launch of the iPhone and what Steve Jobs was demoing on stage, he was talking about your calendar and syncing your contacts, and this is how you do your emails. He wasn't talking about streaming video. Post 2010, we see the mobile phone shift to a handheld entertainment device, because this is what teenagers want to use it for. They want to share video, they want to share pictures, they want to watch TV, they want to play video games. They don't really want to send emails to their office environment to see how things are going with the new deal, right? And so sometimes when people look at shifts like this, they go, okay, well, it takes time for technology to mature. So the cameras started getting better on phones, and the quality of the displays started getting better, and that's what created the shift. That's what happened. And the data doesn't really support that so much. So we have the very, very first commercially offered cellular phone released in 1983. So the brick phone that we're all used to seeing in parodies of the 1980s. And then we have a long period of time before we get up to this as an entertainment device in 2010. And in between there, we have the first event is streamed over the internet in 1995. Now, for those of you like me who were active in 1995 in technology, you probably think to yourself, yeah, but it sucked. And you're right, it did suck. It was very early stages of technology. It definitely wasn't ready for prime time. But by 2006, which is still like really like far away from this turning point that we see, YouTube has hit 100 million views per day. So by the 2000s, we're there. Like we have the technology already, and we still haven't really hit the point where we're using our mobile phones as entertainment devices. The first camera phones were released in 2002. And this is a particularly interesting case because rather than advance, we actually briefly started to go backwards. So in 2007, Nokia released the N95, which had a 5 megapixel camera on it. And then in 2008, the HT Dream came out and the iPhone 3 came out, both of which I think were pretty much more successful than Nokia's offering and had worse cameras than Nokia's camera. So for a couple of years, we saw that we had the ability to produce really great technology, and we were actually like downgrading it for commercial markets. So what we're actually seeing here is a difference called alignable versus non-alignable differences. And so this is kind of a marketing science terminology. And alignable differences basically means that we can compare a product that we buy to a product that is new and figure out how they're different from one another, how they're better from one another. So like we have a rain umbrella and a beach umbrella. Like if I have bought a rain umbrella and I own a rain umbrella, but I can sort of guesstimate the value of a beach umbrella by referencing what I already know about a rain umbrella. I can tell what use cases it is and is not for, and like where it may plug into my life. However, if I have a rain umbrella and a typewriter, I know absolutely nothing about the typewriter from the rain umbrella, right? And this is significant because consumers make purchasing decisions based on their ability to assess value. And like, how do I know what a good price for a typewriter is? Is it $200? Is it $500? Is it $1,000? I'm sure some of you are thinking it's $0 because just get a laptop. What would you need a typewriter for? But like they do still sell them and people do still buy them. So it's hard to assess the value without something to compare it to. And knowing that I might spend $20 on a rain umbrella tells me absolutely nothing about whether $500 is a good price for a typewriter. So generally when we think about technology and how it advances, people assume that products that are the most innovative are more likely to succeed. But actually, what the consumer needs is alignable differences. They need reference points to things they already buy or already use to understand whether or not it's worth their money to buy this thing you're trying to sell them. And the thing about reference points is that it's all about exposure. So what we see happening in 2009 and 2010 is that we've reached sort of a tipping point where enough people have cell phones that people for whom the business use case of cell phones is not really valuable are now starting to understand what other things cell phones might be able to do and starting to kind of condense into markets. And particularly with teenagers, it was their parents. So around 2006, the percentage of American parents that owned cell phones reached its sort of maximum saturation point. It got to about 90%, and it sort of never got over that point. Like everybody who had bought a cell phone, who had a teenager, had bought a cell phone, right? And that's the point where we really start to see the level of teenagers with cell phones start to accelerate quite quickly. Most likely what happened is that the parents got used to always being in contact with their office environment and then turned to their children and thought, I want to know where you are actually, and I want to be able to always communicate with you, and then started introducing their children to cell phones. Broadly, we kind of describe these sort of shifts as like service dominant logic, or sometimes abbreviated to SD logic. And what service dominant logic describes is that all companies, even if you think you are selling a product, are service-based businesses. Because what you're doing when you're selling a product is you're trying to solve a problem for the consumer. The consumer needs to want your product and think that it's going to do something positive in their life, even if your product is like potatoes, right? So all companies are service-based businesses, and they all operate in the fashion of service-based businesses. And the other thing that we take from SD logic is this popular culture idea of how like you as the consumer are just a mindless sheep, and like the company tells you what your wants and desires are isn't true. That markets are actually created by a active, unending collaboration between the consumers and the companies themselves. That we are creating markets for the products that are sold to us, and that the corporations are contributing and directing where those markets go. And so from a technology point of view, this should ring a bit true, because we've all been around long enough to see products that were maybe like a year or two too early, and that like a few years later, an identical product, like literally an identical product came out and just went gangbusters around the market. But that when these original products came out, they actually did not do well and were considered failures. So this happens because as companies optimize for increasing market share, they are getting more and more people to buy into a particular form of technology, and they're creating new markets because people for whom that product could be useful if just one thing was different about it start to gather and become actual markets that can be sold to. So all of those people who saw cell phones and just thought, oh man, if the screen was just a little bit bigger, I could stream all my YouTube videos, sort of started to hit their tipping point around 2010. And in the case of cell phones, what we see happening is that you can use a device that's meant for entertainment to check your email just as easily as you can use a device that's meant to check your email. And so we see one market completely overtake the other because it's much, much larger than the original market. So as a result, BlackBerry, which when I was in university was like the best cell phone on the market, it was like the top cell phone, is now functionally dead because you can't really use a BlackBerry for all these entertainment purposes, but you can definitely use your iPhone to check your email. But it doesn't always go that way, right? Mainframes still exist despite the fact that we have the cloud. So let's talk about the mainframe. Mainframes as a commercial product started to appear in the 1950s, and they were massive and also extremely expensive. They're like full room computers, and the only organizations that could really afford it were governments, banks, and universities. So like big, powerful institutions. And they bought their mainframes so that they could do their advanced computer calculations, and it was great. But by doing that, they increased exposure to smaller organizations that didn't have the space to put a mainframe, and you usually didn't have the money to put a mainframe in it, but still understood the value of what was going on in these much larger institutions and wanted to be part of this new era of computing as well. And so this led to the advent of the mini computer. And so the prefix mini here is slightly misleading because these computers were roughly the size of half a room versus like a room full of computers. They're not what we would consider mini anything in this day and age. But the mini computer led ultimately to the advent of the microcomputer, which we know better under the name PC. So we saw a market force pushing computers cheaper and smaller and cheaper and smaller and cheaper and smaller. And in between the mini computer and the PC, we had a group of organizations that wanted to use computers, did not have enough money for a mainframe, did not have enough money for a mini computer because mini computers also cost thousands of dollars. And these organizations kind of looked at this and went, can't I just borrow yours? And therefore, in like the 70s, we got the onset of time sharing. So this had been a feature that mainframes could do before 1970, but 1970 is when IBM finally committed and said, fine, you can time share on your mainframe. And it was generally done through something like this, which was, this is an IBM remote terminal. And so originally these remote terminals were connected to the mainframe through fairly thick cables. But over time, as the 70s go on, people start connecting to mainframes across all sorts of different mediums, including telephone lines, and which would eventually become the internet. So now we have two axes, right? We have one market force pushing computers cheaper and smaller and cheaper and smaller. And we have another market force pushing data transmission faster and faster so that we can dial into the mainframe and send it more and more and more data. And what's interesting about this is that these are actually two different set of companies that are doing it. You have the computer manufacturers who are pushing computers cheaper and cheaper and cheaper, and you have the telecoms that are pushing data more and more and more and more data so that you can do more remote work on your mainframe. And let's see how that progresses across the decades. So the column in the middle is kind of like typical bandwidth offering that you could get from a telecom. It's hard to say it's an average because like bandwidth is a variable thing. And then the column next to it is the cost adjusted for inflation of a first generation brand new computer typical of that decade. So no one was spending $6,000 on a computer in 1980, but they were spending like $500-$600, which in today's money is $6,000. And so in 2000, we see broadband start to really pick up speed and more businesses and organizations are getting broadband. And in 2010, mobile phones actually have enough speed and bandwidth to really start to make an impact. So the number for 2010, if you look at it in broadband terms, is actually much, much higher than that number. And so if we look at like the percent change of these factors, you see that there's almost like a perfect mirror image of these two trends. We have the bandwidth increasing between 1980 and 1990 and then slowing down pretty dramatically between the 90s and the 2000s and then like exploding again between 2000 and 2010. Whereas the price of computers, it's a modest decrease between the 80s and the 90s, and then in the 90s and 2000s we see a huge decrease in the cost of computers, and then when we get into 2000s it starts to slow down again. And so for reference, because we do see this big explosion in between the 80s and 90s, we're really only getting up to about 30 kilobits per second. And 30 kilobits per second in computer terms is like nothing, right? It's like that's the absolute floor of like a Skype chat where you have no video, right? Or it's just a voice chat. And if you wanted to stream music, you'd need at least 60 to 90 kilobits per second. And if you wanted to stream video, the floor is basically like 500 kilobits per second. So that's sort of a reference point, because what we see during the 90s and the 2000s is this is the era where everybody's like, get off your mainframes, that stuff is done. We have these new cheap machines, they're super powerful, and put all of your applications on your cheap PCs. And so, like, this is a very famous quote that, like, mainframe aficionados like to throw out there a lot. And it hit InfoWar, like, right in the middle of that period, 1991. This is why we see that shift. When hardware becomes cheaper, personal computers became the way to go. Like, put everything on its little machine, have a fat client, you're good to go. That's the way of the future. When data became cheaper, now suddenly we're going back to the old patterns that we saw with mainframes, except we're calling it the cloud, right? So what I emphasize with people when I work with them on their legacy systems is that the question of when do you migrate is that all migrations should add value. So the first thing you have to figure out is, like, why are we switching technologies? Why are we switching paradigms? And what value is it going to bring to the table? And let's not just assume that it adds value simply because it's new and we saw a bunch of really cool conference talks about it, right? So let me give you an example. I have a very good friend of mine who runs a rack of servers, for the U.S. Department of Treasury. And what they do with these servers is they run a Hadoop cluster where they process a whole bunch of financial data looking for financial crimes. About a year ago, her new boss came to her and said, like, we want to move this to the cloud. We are modernizing our infrastructure. We're just going to take this and we're going to buy a big data as a service plan from AWS or somebody else. And we're going to get rid of these servers and it's going to be way, way better. How many of you think this is a good idea? Oh God, almost no hands. Excellent. I have succeeded in my mission here. So the argument is the cloud will save us money. And is that true? Well, some of you may know this from experience, but Amazon actually charges you for moving your own data around. They used to charge you for putting your own data in the cloud, but they stopped doing that, and I wonder why. But they definitely charge you for taking your own data out of the cloud, and they also charge you for moving your data from region to region, and I believe VPC from VPC, if that's the way you're setting things up. So this is a bit of a simplified example because they build different regions differently, and of course, if you have a lot of data, they will give you some sort of package deal, but it gives you a sense of what we're talking about here when people automatically go, we need to move to the cloud because the cloud is cheaper. If you are being billed about 2 cents per gigabyte, and you have 100 gigabytes, that's $2. That seems super great, right? You have a terabyte, that's $20. Still seems super great if you're a large organization. If you have a petabyte of data, that's $20,000. And so now that's starting to get pretty expensive, right? So the question I ask people when we talk about migrating to the cloud, and please don't misunderstand me, I'm not like a cloud cynic or anything. I do actually really like the cloud. It's just like value add, right? It's like, how much data do you have? And more importantly, how often do you have it? Because having a petabyte of data that it took you 5 years to collect is a completely different use case from having a petabyte of data that it took you 5 hours to collect. And then where is it? Because it's always going to be cheaper and faster to process your data where it already is in the first place. So the thing I want you to take away from this is that technology does not advance in a linear fashion. It actually tends to advance in a cyclical fashion as different forces around it change and shift over time. So the question one has to ask when approaching even non-legacy systems, even the systems that you maintain today, like somebody is going to come along at some point and say, hey, we need to put this on Kubernetes, or hey, this needs to actually be serverless, or hey, I don't know, there's a new programming language out, let's say Darklang, and everything needs to be in Darklang now, so just rewrite everything in Darklang. So at some point you will have this experience where someone is telling you you need to move the system from point A to point B. And the question really should be why is this valuable? And some things that we can explore in talking about why these migrations might be valuable is first of all, does it save us any money? And if so, how much money does it save us? And where are we getting those cost savings? And are there any expenses that are going up as a result of this that actually cancel out all of those cost savings we see somewhere else? Does it make the developers' lives easier? Continuous integration definitely makes developers' lives easier in a lot of different ways if you do it right. So if it makes your developers' lives easier, how does it do that? And are there things that they have to change about their process, and how difficult are those changes? And then the last thing that I like to consider is that does it improve the overall stability of the system? And this is the argument I make for COBOL mainframes, because the reality of it is that people who know COBOL really well and know how to work on COBOL applications really well are basically dying or retiring, and that does not contribute to the overall stability of your system if you're dependent on a COBOL mainframe. So there is a lot of value in that particular use case to figuring out what the future looks like for your COBOL applications. But you need to be specific and you need to test those assumptions. Don't just assume that because something is new, it's automatically better and it's automatically cheaper and it's automatically more stable. Because neither one of these scenarios, either let's just leave technology alone until it burns itself to the ground, or let's keep changing it until our developers quit in absolute frustration, is a good way to manage your technology. But sometimes when I talk people through these concepts, they take it to a really strange place, and they say, well, okay, cool. If technology works in cycles, then what I should really do is just wait for technology to circle back, and then everything I'm using will be trendy again, and I'll be fine. And if you've ever worked on a mainframe, you just basically have that reaction to that statement. Because the thing about the cycles that we see with technology is that you break technology down into a wide variety of different components. This is just one way we could think about technology and what technology is. We have hardware, we have software, we have interfaces, we have protocols. But I could have broken it down into more categories, or I could have used different categories. It's just how you think about that taxonomy. But in any case, All of these things are sort of advancing in cycles, and all of these cycles are moving at slightly different paces. So the idea that your old system is going to accurately reflect some modern system in the future it's just not going to happen. And what we generally end up with is two forms of technology that are separated by a huge period of time that have some commonalities to them and seem like they should work together, but actually have a lot of differences in their core assumptions and some of the other elements of how they're created that make that leapfrog migration super hard, or that interoperability super challenging. So I come back to this necessity for value add. Figure out how your migrations are going to create value before you invest your time and energy in doing it. And so I think I have a little bit of extra time. Would you guys like one more example? Yes. Wow, excellent. I was worried people would be like, no, I'm fine. I want to go grab a coffee. So, all right. So there is one more pattern that I've been studying around how computers and technology advance, and I like to call it cannibal code, which means that we tend to cannibalize interfaces from other forms of technology in order to increase adoption of our new form of technology. So I have a question for you guys. How long should a line of code be? I think we all think that code should be in short lines, right? So can we all agree on that? How long should it be? How long is too long? 23? Has anybody heard the idea that it should be 80 columns long or 80 characters long? I'm getting some head nods now. Okay. So 80 column width is kind of the standard that people like to fight over the most, at least as far as I'm concerned. Does anybody know where this comes from? Why 80 characters? Excellent. Yeah. 80 columns is the size of a punch card, right? Okay. So next level. Why did the early computers use punch cards? You think of this is the principal data input method of early machines is we're going to take a piece of paper, we're going to punch some holes in it, and we're going to feed it into the machine, and the machine is going to know what that means. Like, from a modern perspective, that's a bizarre concept. Why would anyone do it that way? Any ideas where that comes from? Sorry? Yeah, so that is one. So what's interesting about this is that this was actually an idea, this idea of like storing data through paper that you've punched holes in actually kind of reoccurs in a bunch of different places in a bunch of different contexts. And so one of the places it occurs is with 18th century French weavers who figured out that they could do way more elaborate patterns if they used essentially pieces of cardboard with holes punched in it to tell the loom when to drop and lower the thread. So they were able to produce these high quality rugs in a much quicker fashion than they were before because they were essentially building programs out of these paper punch cards. So that's one place where it exists. But if you look at like the history of like the first mainframes, the first computers that IBM produced, what they were actually basing it off of were railroad punch cards. Like when you went to when you're on the train and the conductor was like punching holes based on like who you were and where you were going. And for modern day computers, the most direct ancestor is actually the telegraph. So this is an idea that appears over and over and over again and sort of kind of coalesced into technology. And most people, when they think about the telegraph, they go, wait a minute, Morse code, like the guy sitting here going dot, dot, dash, furiously writing out what the message is. That's how telegraphs work. And it wasn't the beginning. But over time, telegraphs began to optimize based on human error. So when you have like the traditional mentality of what people think of when a telegraph, it's very difficult. There are lots of opportunities where the message can be garbled by just basically the person that you're putting in the middle of this communication relay. And so over time, as telegraphs became more and more popular, what they started to do was look at it in terms of, well, hey, if we put something in between the person and the telegraph that the person can actually double check, like something like physical, like a paper record, then we can actually now start optimizing for better data transmission and the convenience of the machine. And so that's what we see happen. If you can think about when you go into any login form and you have to type in your password, how many times do you mistype your password versus just having a normal text field where you have a visual reference point? That was what was going on with the telegraph, is because people couldn't tell if they've mistyped something, they were more prone to making errors. So as a result, the telegraph started operating, basically the human would use a printer that would punch out on paper tape. And then they would load that into the telegraph. And once they had the physical medium, now they no longer needed to optimize the codes for minimizing operator error. They started optimizing it for maximum data transmission, which means we got this thing called baudit code, which is a 5-bit binary code system. So going back to this idea of reference points and how technology advances, we had this reference point from telegraphs and we imported it into computers in order to load data in and out of it. And now modern day software engineers on the internet argue passionately about whether they should go over 80 characters in their code length because of telegraphs and 18th century French loomers. So thank you very much for listening to me this morning. It's been a great pleasure to speak to you all. I'll be around all conference, so please feel free to come up and chat to me about whatever archaic old system you have running in the basement of your company right now. Thank you.